Howdy everybody in YouTube land. I have yet another floppy emulator sent in for repair. This one, same thing happened to it. The CPLD went into latch up and was fried. So that's got to be replaced with another one, but I'm also going to do a resistor mod to it just like I've done to mine. That's over here if you remember from an earlier video. Now, this has worked fine, although I do want to say that there is a but. I used 1K ohm resistors, which is what I have here, and that's what I'm going to use there. But I've noticed with some machines, it can be a little picky if it detects the disk or not. Most of the time it's fine, but every once in a while there might be a weird situation where it won't detect it. And I think it's because I need to go down to like 220 ohms or 100 ohm resistors, which I don't have on hand. But the more important thing, though, is to actually perform the repair and get the modification done. And it'll be up to the original owner if he wants to swap these out for, different value resistors. And, depending on the machine he's going to use it with. But I've found most machines it's okay, but not all. But we're just going to roll with it because that's what we have on hand. So let's just fix it, because the thing is, with a damaged CPLD, it's not going to work on any machine. So it doesn't even matter. So just like before, what I typically do is I'm going to remove this 20-pin connector. And to make things easier, I'm going to Dremel off and get rid of these pads on both the top and the bottom, and just open up a little bit of this one for ground and just solder my grounds like I did here, because these are all my grounds. And then I run a jumper wire up to here from this pin, and then on the other side, because all of these here are open, they're not used, so on this side here just run all the resistors and we are golden. So alright, step one, let's warm up this desoldering iron and remove that connector, because I want to try to reuse it. And there we go, we got the CPLD replaced. I'm waiting for that thing to cool down. But yeah, it's been replaced now. The new one is in position, so now it's a matter of getting this all dremeled out. So it'll give me an edge to actually put this in place. Because the goal here is to just slide this in between the PCB here. And just kind of use this as like a support basically. So that goes on there. And then we solder on the grounds. And then we solder in all these connections over with the resistors. And that is it. This thing's done. And that should fix our problem. Oh, and we got to reflash the CPLD too. Because luckily, this thing has a bootloader. He wrote the bootloader to be able to flash this on the fly. So that's certainly helpful. Otherwise, you'd have to have a Xilinx programmer. And yeah, that's no fun. And there we go. Little bit of Dremel action, 8-bit guy style. And there we go. So now, just turn the soldering iron back on, and we get this guy positioned, because what I'm going to do is just this right here. So these are the 4 that are ground, right? So the way we're going to do this is position this just right so that that ground pin, because these 4 are ground, so that one will be over that. And that will hold it in place. It'll be slightly off center a bit, but that doesn't matter. I think we'll be okay with this, just like we did with mine over here. But I'm not going to just seal it in like I did on mine, just in case the resistors are wrong and he wants to change them out. So I'll leave them be at that point. But other than that, this should fix the problem. Now I have the connector soldered in from the bottom. Now all we got to do is just start adding the resistors in one by one, bending them down. I'm just going to tack them on the top, trim them there, and just start cinching them down, just like what I did on the first one. And that's pretty much what we want. So they're trimmed down now. I just gotta, these might be a little too long, but I just gotta, I gotta trim them some more, but just gotta push them down, pretty much like this one here, and solder them down one by one. Alright, so the back side, all we had to do was just run this one wire, and that's the VCC power. Now, when I was dremeling the top, I went a little bit too far over where that VCC trace is. So that VCC trace is paper thin. So I might need to patch that, unfortunately. So from here to there, I might need to run a patch wire. I don't know yet, but it's razor thin. Other than that, it seems to be good. So all we gotta do is get a computer up here and get a cable, get it plugged in, and get the firmware flashed on it, and it should function. Well, we hope. So here we go. I think I have the firmware on this one, but I don't recall. So power on. So if we do... Yeah. No. Alright, bin not found. Alright, so what we're going to need to do is try the other one. Ugh. Now I've already fixed this thing once. Why are you... Never mind. Anyways, I give up with that thing. I think the flyback is starting to go in that one. Okay, so let's try... You're not it. You're not it. Oh, I'm gonna need to go get another SD card. 1 second. Alright, so let's try you. I'm hoping the firmware's on this one. I know it was on one of these. Oh, there we go. No. I thought this thing had the CPLD firmware on it. I guess not. Okay, so... Disk emulation mode, Macintosh. Okay. Yeah, we know. Why isn't it? I'm gonna have to go find the CPLD firmware. I found an older version which contains both the CPLD and the firmware image on the same file, so let's see here. There we go. Yeah, see, it wasn't working. Okay, so now I have to reflash the firmware. Alright, self-test okay. There we go. Alright, so now we don't have that error anymore. So I can now put the new firmware on here and hopefully it updates everything. Alright, so now I have the latest firmware on here. Hopefully it'll recognize the CPLD this time and flash it. Flashing the bin. Updating CPLD. Yep, that's exactly what I was looking for. Alright. Here we go. Macintosh stuff. System disks. Let's run. Is there? No. Let's do 1 of 4. Which emulation mode is it in? Oh, yeah. That's why. Ah, crap. Oh, man. You know, Mike, pay attention to the firmware, you choose the... Oh my god. Yeah, I did the... Yeah, ding, 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 ding. Hold on. Let's try this again. Updating CPLD. Here we go. Now, hopefully... Oh, there we go. Macintosh emulation mode. Golly. Okay. See if it goes. Track 00. And that's a negative. So, yeah, it doesn't like these 1K resistors. Little too big. Little too big. Well, that's a shame. Yeah, I'm going to downsize the resistors, which means I got to order the right ones because 1K isn't going to cut it now, is it? So, okay, let's reboot this. Macintosh stuff, system disks, let's do 7.1 disk tools. Alright, let's see, reset button. Well, that's an interesting fault mode. Didn't like that. Yeah, I think it actually corrupts the SD card. That's an interesting bug. Whoops. System did. Let's see. Yeah, it's not. Nope. Alright, so we've got to do something with the 1K ohm resistors. They're not quite right. It works on mine, but it's not really doing it on this. But yeah, I bet if I plug it directly into the board and these floppy drives are not plugged in, it would work. Because I think I recall having this problem with mine on a different machine. So yes, 1K might be too big. These might need to be about 220 ohms or so. You know what? I just realized something. So, remember, an SE and an SE30 has a Bourne's little network filter between the internal and external ports, which adds series resistance. So there's already series resistance added with series resistance, so that explains a lot. But interestingly enough, the newer version of the floppy emulator already has 1K resistors in series here, like this one does, but it also has 330 ohm resistors for something. I don't know what, unless I reverse engineer the board, but it has 330 ohm resistors as well as 1K ohm resistors, because there's a resistor network that has 4. There's a resistor network that has 4, so that's 8 of the 10. But then where's the other 2? So I'm thinking a couple of these need to be a lower value, because on the newer version of the floppy emulator, that's how he's got it set up. So it makes me wonder if I need to change a couple of these out, but not all of them. I don't know. I'll have to look into that. And the best way to do that is to take my floppy emulator apart, because I have a newer one. I bought a second one. If I take it apart, I can compare and contrast and see what the differences are and how Steve handled that. So I think I'll do that instead of just changing them all out. Because he is using 1K for at least 8 of the 10, but there's 2 left over that he's not, so that's the modifications I need to do. Here's what I've found so far with the newer version. So, I've got the pinout of this pulled up over here, by the way. So, these first 4 are ground, especially on the original floppy emulator, but on this design, 1 and 2 are ground, but 3 and 4 are connected to the resistors and into the CPLD. So he must be using those for additional functions like Apple II or Lisa profile or something. He's doing something funky that only this version can do, where this one can't. So that's number one. So I'm going to ignore that right now. But we got phase 0, 1, 2, and 3, which is pH 0, 1, 2, 3. So pH 0, 1, and 2 are 1K ohms, just like I'm doing here. But pH 3 is connected to the 330 ohm. Okay? So pH 3, write request, and head select are all 330 ohms. But then it gets crazier. So in disk, or disk in, is connected to the 1K. But then we have a read line, which is the next one down here. The read line is connected directly to the CPLD, right here where that VIA is. So they're not going through a resistor at all on that one. So that's dangerous. So that's the read line. And then we have the write line, which is going through the 330 ohm. And then we have PWM, which is going through the 330 ohms. So I find that interesting. So in my case, even though I used all 1Ks, well, there's one of these that has to be a jumper. And, well, he made it a jumper. And then there's like 3 of these that are going through 330 ohms. So we've only got like 4. Actually, we've got 3 that are 1K. We've got 3 that are 1K, and then 3 that are 330 ohm, and then 3 more 1Ks with a jumper. So that's what we have to do to follow this format. So whether this one blows up CPLDs or not, I don't know, because he does have this one line going through a directly to the via into the CPLD. I don't like that, because if something happens, it starts drawing current from that read line because it goes into a latched up state. It's going to do this. It's going to have the same exact damage. So unless Big Mess of Wires Steve figured out that the read line's not the cause, it's something else, I don't know, because he's the designer of this. I'm just trying to repair the stuff. So I think what I've got to do is I'm just going to copy what he's done and see if it solves my problem over here. Because if it does, then I need to take mine and do the same thing to it. So it's a good thing we're debugging this as we go along. Alright, so here's what I did for the thought of experimentation here. So I went ahead and changed these 3 out with 330 ohms. And then I put a 33 ohm down here instead of running a jumper wire, because I still don't like the fact that it's connected directly to the CPLD. It might have to be, but we'll see what it does with this and see if that works. So why don't we just go ahead while we go ahead. Anyways, get this all plugged in together here. And hopefully it works. I'm pretty sure the this Mac has the FDHD ROMs installed, so it should mount the disk image. So here we go. Lido boot. Let's see if it works. I hope. If it doesn't, then I have no idea. That is no. Oh. There it goes. It's working. Never mind, it's just being slow. Yay, it's working. So yes, I just had to lower the resistor values on 4 of these resistors. So there we go. 3 1Ks there, 333s here, and then or 330s I mean, and then a 33 there. So it goes 1K, 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 330, 330, 330, 1K, and then 33 instead of just a jumper wire. So yes, it works. Wow, that thing's bright. I gotta turn that thing down. It's, yeah. Okay, so yes, everything works. All right. Now that we documented what it's supposed to be, I can seal that stuff in with some glue like I did on the back side. And then I got to put this mess back together. But that's it. It is fully working, and the only reason why I did this video and released this segment of the video is because we did some experimentation, and that's what makes it fun. So if you enjoyed this, don't forget to hit the like and subscribe and all of that fun stuff. And if you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.